Hello students and welcome to my channel Maths Hub. So in my last few videos I'm talking about graphs, and in my last video I talked about the handshaking lemma. So today let's learn the different types of walk, that is trail, path, circuit and cycle. So let's come to the first definition, that is a walk. Now what is a walk? Walk is basically a sequence of adjacent vertices or edges in a graph. Now, for example, this is a graph which has 5 vertices and some edges are connected to each other with the help of some green and black lines, right? So we can say that one of the walks from 1 to 2 is 1 to 3 is 1 to 2, then 2 to 4, 4 to 5, and then from 5 to 3. So it is just a sequence of adjacent vertices and the edges in the graph. Similarly, we can also say that another walk from 1 to 3 can be 1 to 2, then 2 to 3, then 3 to 4, then 4 to 5, and then from 5 to 3. So here there is no restriction on the number of vertices and no restriction on the edges. You can travel any vertex and any edge any number of times, but you have to keep in mind that whatever are the initial vertex and the terminal vertex from where the walk is required, they should be at the corners, and rest you can make a sequence of adjacent vertices and the edges, right? Similarly, another walk from vertex number 1 to vertex number 3 can be 1 to 2, 2 to 3, then 3 to 1 again, then 1 to 2, 2 to 4, 4 to 5, and 5 to 3. So here you can see that you can construct n number of walks from one vertex to the other, right? So you have to just remember that walk is basically a sequence of vertices and edges, and there is no repetition. You can repeat any number of vertex and any number of edges any number of times, right? Then, so that is what I was telling you. So a walk can contain the vertices and edges multiple times, right? Okay. So now let's see that what can a walk else be. A walk can be open or closed, right? So when can a walk be open? A walk is said to be open if the first and the last vertices are different, right? So any walk can be called open if the first and the last vertices they are different, right? And similarly, it can be called a closed walk if the first and the last vertices are same. That means when it is an open walk, obviously the initial and the final vertex, they will be different from each other. That is why it is open. And when it is a closed walk, then the initial and the terminal vertex have to be the same one, right? So this was about a walk. Now let's talk about the another type of walk. So let's take some examples of open walk and closed walk. So the same example is here, and you can see that an open walk from 1 to 5 vertexes, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. Why it's an open walk? So you can see that the initial vertex is 1 and the final vertex is 5. They are different from each other, right? Similarly, if I talk about a closed walk, so any closed walk from vertex 1 to vertex 1, I have to keep in mind that I have to start from vertex 1 and I need to come back to vertex 1, traveling any number of vertices and edges any number of times. So how we have traveled? We have traveled from 1 to 2, then 2 to 3, then 3 to 2 again, then 2 to 4, 4 to 5, 5 to 3, 3 to 1. So here you can see that the initial vertex is also 1 and the terminal vertex is also 1, and hence it is called a closed walk, right? Now, what is known as the length of the walk? Length of the walk is the number of edges that are present in the walk, and it is basically it is one less than the number of vertices in the walk. So if I talk about the first one, 1 to 2, 2 to 3, 3 to 4, 4 to 5. How many vertices are there? 1, 2, 3, 4, 5. So the length of this walk has to be 4, right? So you can check it otherwise also. 1 to 2, 1 length, 1 edge. Then 2 to 3, second edge. 3 to 4, third edge. Then 4 to 5, 4 edge. So how many edges were there in this walk? There were 4 edges. So the length of this walk becomes 4, right? So this is one technique of calculating it. The other technique is you count the number of vertices and subtract 1 from it. That will also give you the length of the walk, right? Now, let's come to the next type of walk, which is known as trail. Now, you should be knowing the definitions of all these types of walk and you should know the difference between them, right? So now what happens in a trail? Now, trail is an open walk where the vertices can repeat but not the edges. So, if you just go back to the definition of walk, you could travel any vertices and any edges multiple times, right? So, there is no restriction. Now, when we are talking about a trail, the vertices they cannot repeat, they can repeat but not the edges. That means there is a restriction on the edges, right? So, now I will take the same example throughout. So, here if I want to know a trail between 1 to 3, I can say a trail is 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then from 5 to 3. So here you can see that I have repeated the vertex 3 two times, but none of the edges are repeated. So this type of walk can be referred to as a trail, right? Then similarly, we can classify open trail and closed trail. Open trail will be when the initial and final vertices are different. Closed trail will be when the initial and the final vertices are same. Right? Though we are saying that vertices can repeat, edges not. So here again in a closed trail, the only the initial and the final vertex will repeat. So here from 1 to 1 we can say 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 3 and 3 to 1. So you can see that none of the edges are repeating in this tree and since the initial and the final vertices are same, so it is called a closed, right? Okay. The next type of walk is a path. Now what is a path? Let's see what is a path. So path is an open walk with no repetition of vertices and edges. So slowly and gradually we are increasing the restrictions. So in a path it is open walk. Now we have restrictions on the vertices as well as on the edges. Both cannot repeat. So in the same example, if I have to describe a path from vertex 1 to vertex 5, it will be from 1 to 2, then 2 to 3, then 3 to 4 and 4 to 5. So you can see none of the vertices nor the edges are getting repeated, right? Again, if I want to choose a path from 1 to 3, I can say it is 1 to 2, 2 to 4, 4 to 5, 5 to 3. You can also choose some other paths, right? Okay. The next type of walk is a circuit. Now, what is a circuit? As the name suggests, it needs to be a closed one, right? So now what happens? A circuit is a closed walk where the vertices can repeat but not the edges. So here, so it is a closed trail in fact. You can also say that it is a closed trail. So vertices can repeat but not the edges and it has to be a closed one. So again in the same graph, we can say that 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 3 and 3 to 1. It's a circuit. Why? Because you can see that it is a closed trail. Here vertices are repeating but not the edges. Right? Then the next one. 1 to 3, then 3 to 5, 5 to 4, 4 to 3, 3 to 2, 2 to 1. So again it's a circuit from 1 to, right? Next, cycle. So cycle also from the name it suggests that it needs to be a closed one. Now what happens to the restrictions on the vertices and edges? It's a closed walk where neither the vertices nor the edges can repeat. Now since it's a closed walk, so the only possibility is that the first and the last vertex can repeat. They need to be same. Rest, there is no repetition on the vertex set at the exit. Right? So here you can see that if I call 1 to 2, 2 to 4, 4 to 5, 5 to 3, 3 to 1, none of the vertices and none of the edges are repeating except the first and the last one. So this is an example of a cycle. Then 1 to 3, 3 to 5, 5 to 4, 4 to 2, 2 to 1. This is also a cycle from 1 to 1, right? So now let's summarize all these types of walk with the help of the restrictions on the vertex set and the edge set. So when we were discussing about a walk, there was no restriction on vertex, there was no restriction on the edges. That means the vertex and the edges that can repeat multiple times. So vertex means that repetition is allowed, right? When we talked about a trail, vertices repetition was allowed, but there was no restriction. The edges could not repeat, right? Then when we talked about path, neither the vertex nor the edges can repeat itself. Then circuit, it was a closed trail in fact, so vertex can repeat but not the edges. And when we talked about the cycle, so here neither the vertex set nor the edge set can repeat, right? So this table summarizes the entire all the types of walks. Now there is a very useful chart which you need to remember while you are attempting for the questions. So whenever we talk about a walk in graph theory, there are two cases that if the vertices repeat and the edges are not repeating, then that walk is called a trail. Now if both the vertex and the edges are not repeating, then that walk is called a path. So we can say that every path is a trail, but vice versa, it's not true, right? Similarly, if I talk about the closed path, it is called a cycle. If I talk about a closed trail, it is called a circuit. Then similarly, every cycle can be a circuit, but not every circuit can be a cycle, right? So if all the concepts of the different types of walk are clear to you, it is very easy for you to get this chart, right? And this chart clears all the definitions of different types of walks in graph, right? So at the end, I have an exercise for you. So this is a graph, and you have to decide out of, I will show you the walks and you have to tell me that which type of walks are classified as circuit, path, cycle or trail. So if I talk about the first ones, I'll do the initial ones and then you can try the rest of the exercises. So if I talk about the first one, we are starting from vertex A to B, then B to G, then G to F, then F to C, C to B again, right? So what is happening here? What type of walk is this? It's a trail because you can see that the vertex set is repeating but the edges are not repeating, right? Let's talk about the second one. We have B to F, B to G, sorry, G to F, F to C, C to B, B to G and G to A. So here you can see that it's a walk because the vertex and the edges are repeating multiple number of times. Then is the third one, C, E, F, C. So we have C, E, F and C. So here you can see that neither the vertex are repeating nor the edges are repeating and the initial and the final vertices are same. So it's a cycle, right? So now, likewise, you can try all these examples. The answers are already given here, right? And that's all. Thank you so much. I hope you understood the video. Do subscribe my channel and do comment and share it with the needy ones. Believe in yourself and you will be able to succeed. Thank you.